Hello, good morning. Welcome to another Random Code stream. I am going to be working on a whole bunch of refactorings that I think I should have been done, that should have been done a long time ago in rocks. They kind of piled up, so I'm going to start working on those. Before I do that, first thing I'm going to do is get the music going per usual. Wait, I need to turn that down. Holy crap. That was going to be pretty loud. Okay. All right, so I'm going to explain what these all are in just a moment, or at least go through the list one by one. The notes are in the branch, so you can go take a look at that if you want. One thing I wanted to mention yesterday, this is really interesting. So one of the things I've been working on the side is just a personal historical project. I wanted my master's thesis digitized, and that's 30 years old. It exists. It exists in Marquette University's library, and technically it says it has a copyright. But I'm kind of like, screw it. Nobody cares. Nobody's ever going to copy that stuff at this point. And you definitely wouldn't want to copy the code because it's crap. I'm surprised it worked at all. But the point is, I wanted a digitized version of it. So the first thing I did is I went through the code manually, line by line, and typed it all in to C#. It was written in C, and I could have done it, I guess, in C again. But I was like, no, I want to put in C#, but not do too much translation. Keep it the same as much as I possibly can. And I was hoping to keep it as a private repository, but unfortunately, what I ran into is when I started compiling it, it took 16 minutes. 16 minutes to compile this. And I'm thinking, there's no way. There's no way that this has to take this long. And because I'm like, the C code, when I would compile in college, I don't remember it ever taking 16 minutes. Now, it's not great code. In fact, again, it sucks, but it should have come, and it wasn't doing like anything really weird or esoteric. You know, it had one method that has a whole bunch of nested for loops, which is awful, but it is what it is. So I reported it, and one person said maybe turn off the nullable reference type thing. I did, but it was still taking 9 minutes, which is really long. And then I forgot. I was going to bed, and I kind of forgot. There's this tool called MS Build. You can use the build log viewer, and what happened is that this person reported that there's one rule, CA 1508, that was taking up the vast majority of time with having the analyzers on, which I do by default. If you look at my projects, like if you go into rocks here and you look at build props, there should be analysis mode all and then treat warnings as errors is true, although that's not really the point here, but having all of them on. Okay, so I did that in this project because that's just what I do. And so I disabled that one, and the build took a second, which is much, much more expected. So seems like the real culprit is this 1508, and I did take a quick look, and it's been reported for other things. Like this was reported by somebody, what was that? Jeez, going on 2 years at this point, and saying that you know, the build definitely goes up if you change from like 8 to 7, I think. And then if you turn it off, it executes very quickly again. And they were looking at build log, and they're like, yeah, this is taking a decent amount of time. So I'm kind of like, I think this is an issue. I think they need to go look at this and look at this analyzer and say, there might be something with it that we need to remove, because you can't. I don't think it's reasonable to expect a user to say a build's going to take minutes because an analyzer is doing what it needs to do. And I don't think that's reasonable. So hopefully that gets fixed, but it looks like it's been reported as an issue, at least now with me and somebody else, a couple of times. So, hopefully that happens. But I guess that's one thing to keep in mind. If you're building C# and you run into a large build, I wouldn't recommend turning off nullable analysis. I think that's helpful. And I would recommend not turning off analyzers, because I think those are helpful too. But there is this tool like they're showing here, where you can run a build with the analyzers reported. And then you can use this tool from this build log viewer to see like what's taking the most amount of time. And I think that definitely helps. And it's something I just flat out forgot with this. So anyway. So let's get back to this one. So I went through the code base and I created a whole bunch of notes. And, this is going to take some time, and I don't know if I'm going to do it all in a string, like do all of these. Put that there. Do all of these in, I'm not even say one stream, but a series of streams. Some of these I might do off camera. We'll see. But these are things that I've noticed throughout the years that have piled up in rocks, and they do need to get addressed, because I do think there's bits and pieces here and there that are duplicated, and there are things that I'm kind of like, maybe I could change this, maybe I could make this a little bit more efficient, maybe I could do this a slightly different way and make it so that it works a little bit better. So none of this is adding a new feature. It's just doing like that kind of occasional cleanup that you have to do when you go through code and go, wait, why did I do it this way? Why did this happen this way? And again, spend that time to go through it and learn. And as I say, again, why am I not using an LLM to do this? It's because this is my go to the gym mentality. When I go to a gym, or for me, all the weights are at home. But if I'm going to work out, I work out. I don't have a robot, or I don't have a forklift lifting all the weights for me. I'm doing it because it's benefiting me. And it helps me learn. When I'm at work, I do use it when needed, but it's something that I do feel is becoming way too much of a crutch. And people, it's starting to, it's feeling like, and in some ways, that people aren't spending the time to really understand what a code base is doing, or what is happening, or what's being added. If I ask, like I've had a task recently at work to create a PowerShell script for some setup on a Windows machine, which I know PowerShell in terms of name, but I've never really sat down and said, okay, let's write a script. So I think I used Copilot to basically help me out and creating it and doing some stuff. But I was also very meticulous in going, well, what does this do and what does this do? And it was also very frustrating that I would do all this work. I'd do as much testing as I could on it. And then I'd make a PR, which now our PRs have Copilot enabled to do reviews. And it would review things and come up with comments on stuff that in VS Code it was telling me to do. And I'm like, what the hell? Yeah. So, did it help out? Yes, absolutely. There's definitely things that I'm like, hey, I want to do this. How do I do this in PowerShell? And then it would give me something, and I'd look at it, and I kind of do a little bit more research on what it's trying to tell me to do. and then I would decide to actually use it. But at least it got me to a starting point, and that's better than what I had before. So, but this is just me doing my thing. This is me learning on my own. Okay. So a whole bunch of stuff, a lot of them, when you start getting down into here, is mostly just combining a whole bunch of stuff that I had as separate write lines into, or write line calls into my write lines method. Because it reads a little bit easier in my opinion. But there are going to be some things on here that I'm going to be questioning, going, wait, why do I do it this way? Or why do I do it this way? So it'll be quite an adventure, because I also know with rocks that it can be very touchy at times, very sensitive to change. And that's kind of why I want to do this, because I want to reduce, it's not fragile. It's just, you know, you're dealing with rules that come from a compiler, from C# effectively. I'm trying to create a type that derives from a type and overrides things. And it can get really hairy in a hurry. There's lots of esoteric things that pop up when you do that. So making one little change can wreck things. Even changing how the code is formatted, now I have to go back and change a whole bunch of unit tests because the format it's not the same anymore. And so that's just busy work. So that's just the nature of the beast that I found. So, but it's good that I have a bunch of tests, because that's going to help in making sure I don't break anything. So the first one's, I think, going to be kind of a interesting adventure. I said, why does verify take so long? Now, to be clear, it doesn't take that long. Okay. This is this website, Benchmark MockNet, that somebody created that looks through a bunch of, hey, Electron, looks through a bunch of mocking frameworks and runs some tests on them to determine their performance, you know, in terms of speed and memory consumption. Long time no see. I've been streaming. I'm back to normal. You know, it's you that's at fault. Just joking. And so this has been nice because it's helped me to continue to say to myself, you know, Rocks is the fastest and consumes the least amount of memory out of all of them. Now there's one down here, still the champion on. This is Verify. But it does, to me, go, well, why is it taking 600 bytes and this amount of, you know, time to do? Can I make that better? I'm pretty much convinced, unless I'm shown otherwise, and that would be fine. That would be more than fine. That all these other ones could be faster. I would be absolutely thrilled if somebody showed me that there's ways to make them even faster or consume less memory. This one, I think there might be a chance. Might. I'm not saying there is, but there might be a chance. Okay. One thing I noticed with Verify is if I go to the code, and this is in expectations. So if I go to expectations here, because if you look at the way the code is generated, so let's go down to just a method void test, and we can go into the generated code. If you come down here, and when, where is it? Down here somewhere? Yeah, Verify. Exams are over now. I think I told you this. Yeah, you told me that you were taking them. I would assume that they'd be done by now. I know that physics was a problem. I remember that. So Verify here, you override it, and that's what's actually called to verify your expectations. And the generated override, what it does is it will look through and say, assuming you did create an instance and an exception wasn't thrown, what we're going to do is go through each of the handlers, and the handlers are set up so that those are the ones that are responsible for tracking when you call methods and what was done on them. And so it's going to call this on all three of them. Now, add range on a list takes an enumerable string. Our verify returns a list of string. And so if you look at the expectations here, what we do is instead of just returning what comes out of the select, we're actually allocating a list for this, which is going to take a bit of time. Now it's possible, and I'm not sure if the jitter is going to do this at runtime, that it might look at this and say, well, you keep returning a list, but this is expecting a, well, what's the phrase? It's expecting an enumerable. So I'm just going to short that, and I don't think it can do that. I don't think it's going to have the capability of doing that. I don't think that would actually be correct. I don't know though. Like, the whole jitter is a mystery to me at times, and what it does. If you don't know what I mean by jitter, just-in-time compiler. So yeah, I don't think it can make that optimization. So what I want to do is I want to just change this so that instead of verify returning a list, it returns an IEnumerable. Now, that sounds great, but of course we need to actually test to make sure that this is going to be speedier and less memory consumption. Okay. And we are definitely going to want to do something where we change, like, I think we can do this where we can create like a custom expectations type and then pass it in like some handcrafted handlers where none of them fail, or maybe that you do have some failures here. And, we can set the type and do all that and do it in a benchmark. So this first one's going to take a little bit of time. I was pleasantly surprised though. Let me make the code a little bit bigger here so it's a little bit easier to read and stream. I forgot. I remember I did this performance project, but I forgot I had these baseline runner tests and baseline tests and this whole structure set up so that I could do like some baseline tests on stuff, which is really, really nice. What I'm forgetting to do before I do anything else is we should really run the performance tests with the baseline runners so we can see at the start of this what I'm doing. Don't worry about the thumbnail. That's no big deal. What I could do is have this baseline, run it, and then at the end of all of this, run it again to see if we made any differences. Now, of course, I'm going to have to run this in the same conditions, which means while I'm streaming, while I have music playing in the background, because you want to compare apples to apples, right? If I did it where I was just running it separately, nothing else is running, those numbers would probably be somewhat skewed. I guess actually what I could do, now that I think about it, is instead of doing that now, because that will take some time, let me put in my notes, before committing, run Rock's performance on the main branch and then on this branch and see what the differences are. That actually could also do the same for the CodeGen tests. That makes a hell of a lot more sense. I think that resonates better rather than trying to do that now. Okay. But I do have this project here, and what I could do is create a test that we just throw in a verify to method. And the verify to method is what returns, it does the same thing as this, except it does that. And then we could have some performance tests to see what the difference is between them. So let's do that. We are in a branch. We have the power. So let's actually figure out what we want to do here. So we want to have, and we have to have a different name because you can't overload by return type only. So we want IEnumerable of string. Okay. Now what we want to do is take that off, and we want to take that off. Oh, and then we need to close that. So that's really the only difference we want to do. And then we want to generate something that has a couple of handlers here, right? And get them to the point where we can just start doing some basic performance tests. So let's put in here, wait. Don't tell me I did this already. No, I don't think I did. Yeah, I don't think this is the same thing. I thought of doing something to test to try to make write lines faster, and then I realized I had already tested that here. This is the old way. This is the current way I'm doing it. And then this is something that actually I've already tested before. So I'm like, no, I don't need to do that again. Verify. So let's create verify. Return value. There. Okay, so we want a public class. Yeah. And what we're going to want here is something that kind of mimics this. And where we're going to want a type. We'll just call it my expectations. Okay, and then what does it tell me? Yeah, we have to do verify. Well, we'll get there. We'll get there. And then in here, we just need to have these handlers. We'll just copy and paste this. This is fine. And then we will rename things. Let's get rid of global rocks because we really don't need it for these tests. Same thing with global system dot. Okay. And then we can have here that. And then that. And then that. Okay, now what are you telling me? Unused field. Oh, it'll be used. Don't worry. And then what we do here now this will be interesting. Because in this case, I think we want to do this like my expectations and then have a class called my new expectations. I think that would be oops. Let's get rid of that. Okay. So this is going to do it the current way, which is to call the one that gives us a list. Okay. Now, what we also want to be able to do is I think if I remember right, don't we turn those off? 860, yeah, we do. Okay. Actually, let's put those at the top here because we want to like do the same thing that we're doing before. Okay. What we're also going to want to be able to do is add handlers here because we want to simulate that we've added some things here. So we're going to have to make these a little bit different and make them internal. Or what we could do is have the ability to add these in here, which have the ability to see on the parent. And change them. That might, you know, fine, whatever. Setting up tests is always fun. But this does give us the fact that we do not have to change these. Okay. And then we'll just have to do some unfortunate copy. We'll change these to my expectations. Oh, and then we need the adornments. We actually don't. We can change this because these are just setup methods. So we can just basically say, you know, for our purposes of testing, we can do just returning voids. We don't need this right now. That's not our purpose. Okay. So we'll do void here. And we take that off. Cool. So you don't have a setups field. Where's the setups field? Oh, it's up there. Okay. Cool. So now we have an easy way from this type that we can just say like multiple parameters. Just trying to clean it up a little bit. And then that will be able to give us that gives us the ability now to set these and then also do verifications on them. Now the problem is that we don't have a way to set. If I go this dot handlers, call count. What am I looking for here? If I come back to the generated code, there should be. Oh, we could just, because the verify is only looking at the expected call count. So we could have something in here to kind of fake it so we're acting like we're calling these, if that makes sense. So we could have a public void call call no parameters. And what that does is it goes this dot handlers 0 call. Wait, what is it doing? First. Okay, so when do we new these up? We have to do them in the constructor somewhere, right? Right, we do that. Right. Okay. I will check it later, Electron. Not right now. So how do I want to fake this? We really don't care about the validity of the parameters or anything that way. We just want to say, like, take the first one that's there and increase its call count. I mean, I am starting to get to the point where I'm almost like redoing the entire code generation thing, but it's looking cringy. That's fine. I mean, don't worry about it. I'm not really looking at making a thumbnail anytime soon. Anyway, what do I want to do here? Because I want something that's somewhat realistic. I mean, the thing is with most of these, if you're mocking something, you in all likelihood are only mocking one thing, maybe two. You know, there's this thing I've always had with rocks, is that the long tail or the hockey stick, in that if you're creating a mock, in most cases you're probably just mocking one member and you're only setting up one expectation on it. So the reality is when you come through this is you're only hitting one of these, and then we'll come into this, you know. The thing is, from a performance standpoint, it would be really nice if we had, like, we have this list that we're allocating that we... The funny thing is, if we don't allocate it, is it actually cheaper to not allocate it and then only allocate it within here if we need to do so? Because well, no, that's not true. We need to have a list here. I wonder if we could default the list capacity to 1. Or maybe even make it, can you do 0? See, these are the things that keep me up at night. Can you allocate var list equal to a new list of string and give it a 0 capacity, and then say console write line list dot, is it length or is it count? I never remember. And then let's try to compile it. I've noticed with .NET Lab recently that it is completely fallen off the cliff. Like, something happened with it that it's not able to compile anything anymore. Which is really sad. Because Sharp Lab also had some very bad characteristics for a while, but I need something that can actually compile. So if I say here, and see, like, it's taking it forever to compile too. I'm like, what world have we run into? Connection lost, reconnecting. Like, can nothing compile anymore online? I think .NET Fiddle is another one. You can see I was actually trying to try some stuff out here. And unfortunately, it doesn't have... And then we need... And then I guess it's probably count, isn't it? Yeah. Okay, so that's fine. We can actually allocate to 0. And just start by allocating to 0. And the reason that I say that's actually kind of cool is because most of the time we shouldn't be adding anything. Right? Jason, do you watch movies and web series? I'm asking because my brother is also a software engineer. Can't manage time to watch movies where... I do. I do occasionally. By the way, if you're new to the channel, you haven't subscribed, please do so. I would appreciate it. I don't watch many shows just because. And actually, we probably have a couple of things we can test out here and try. You know what? Let's do that. Let's just copy that code and change it so the verify does what we want it to do. That'll be probably easier. I was just talking about this with my wife last night about, you know, I saw this message on Blue Sky where somebody said, you know, we all said we're going to cut the cable cord years and years ago because cable sucked. And now everybody has 12 streaming services. That's actually more expensive than when it was with cable. And like my older kid and my wife were watching some of the Fallout shows yesterday. I have Amazon Prime, and now they still put ads in them. Even with Amazon Prime, you still get ads now. It's like, this is... I'm going to try to temper my language here, but that's BS. That's absolute BS. Like, then why even have Amazon Prime? I mean, the whole streaming world has gone completely to crap, in my opinion. And I really don't have much of an... I like watching movies. I like watching shows that are good. But I really don't have much of an interest anymore in... You know, yes, people that are, you know, create content, I think, should get paid for it. But all of the crap around it has gotten completely out of hand. And I don't want to participate in it anymore. I just find it worthless. If anything, I want to cut some of the services that I have because I'm just like, I barely use them anymore. And they're just compiling money. That's what they do with people, is they just, oh, you get a service and then you don't really think about how much money you're spending on it a year. And it's like, for what? You know, why? What's the point? Anyway, old man ranting. Let's do that though. Okay, so let's actually kind of kill what I did here. And let's come into here. We'll still keep that here. And yes, we're going to take all this code. But what this is going to give us the ability to do is to focus on the verification part, which is what we really want. So let's take this off. Okay. And this is going to be my expectations. And then this is going to end up becoming my expectations. No, we don't want anything there. Okay. Just trying to clean it up a little bit. And then we can take this and we can replace that. Hey, both of you, Electron, let's not do that, okay? We can change that to a list. It should be... Yeah, so now we need to copy the interface that we're trying to mock, which is this thing, yada yada. Again, all this is set up, but this actually gives us the, again, ability to test things, which is what we want. Okay. Yes, that's fine. So now we should have everything in place. Yes, we do. Okay, so now we can treat this like our mock, except here The one thing we're going to change as we copy this for different ones is we're going to change what the verify is doing here. Now, one thing that may not have been obvious right away is the fact that I was able to take in a source generator the code that is generated and just copy paste it and do what I need with it. That's actually really helpful. Right? That's actually really, really helpful. Like if you were doing this if I was the author of this and I was the author of MOQ or NSubstitute, I wouldn't be able to do that. I wouldn't be able to take the implementation and just tweak it like this. It'd be much, much harder to do that. In fact, it'd be impossible. Not impossible, but it's being generated at runtime. So this, I can just take this code and now tweak it the way I want it to be tweaked. Okay, so now we have, this is the standard way of doing it. Okay. And I want to have different cases of the let's rename this class to verify strategies. Yeah. I kind of want to group this together, basically saying do it where there's no expectations that have been made, and then do it where each one has expectations, and then do it not with, you can't do it with a void method because you can't set expectations on a void method. You can, but there's only one because you're only saying when it's called. There's no way to differentiate between different parameter calls. So what I'm getting at here is I want a benchmark. Okay. And then I also want to say memory diagnoser here. And then we want to return something here, right? I don't know what to return though. No expectations current way. Okay, so what I'm going to do here is I'm going to say var expectations is equal to new my. Let's change this to current. Okay, because that's what's current expectations. And then expectations.setups. No parameters. Actually, no, I'm saying I don't want any expectations. I'm expecting that this would not be called. So now I can say var mock is equal to expectations.instance. And then we say expectations.verify. Okay. And actually we can do this because we're never using it. We'll be waiting for you. We make really good tea. As long as it's all in good fun. I just don't want something to get out of hand. That's the only thing I want to chat. You know, just keep it respectable. I guess what I'm really testing is the verify here. And I don't remember when I do verify. Yeah, we can call it more than once. There's no real reason why you'd want to, but we can do that more than once. Okay. So I don't want argument sources. Benchmark.net setup. Setup and cleanup. A method is marked with global setup will execute once per a benchmark method after initialization benchmark. executed once. So we'll do global setup. I think that's probably what we want. So global setup, public void, global setup. So we're going to want a private current expectations, no current expectations. And then in here we want this dot no current. Actually, we don't even need to do an instance on it. Well, no, we do. We actually have to, because otherwise it will fail because the call will say you never made an instance of it. Okay. Let's not get... I'm going to ask you, can you just stop? Let's not get into the whole nuclear war thing and everything like that. I'm already thoroughly disappointed with my current leadership's activities and, well, not just the last 24 hours, but in like the past year or so. It's a clown car fest here. So let's not get into, please, not nuclear war, not anything like that. Let's just stop that. Okay. So here, now we can just say this dot no current expectations verify. We do want to return something because I think with benchmarks, if you don't return something, your calls can be optimized up. But I don't think in this case that matters. Like we can just do that. I am going to move that up here because I really don't want to deal with that. So this gives us a test to say how fast is verify going to work with the current way of things. And then what we could have is we could have one current expectation and then many. And one all fail. And then we could do the same thing here. Well, no, we can't, because if we don't set expectations and then we call some of these things, those calls will actually fail in the mock. So we can't do that. We can say with the one, which is to say we have expectations and then we just don't call those, but we can't do the opposite with the none. Those will fail at invocation on the mock. Okay, lots of things to... So now we want one current expectation, where we say var one current. And then what we're going to do on one current is we're going to do no parameters, one current, one parameter, which will just pass in 3, it doesn't matter. And then one current, multiple parameters, 3, 3. We love 3. Okay. And let's separate these out a little bit so they're easier to see. Now what we also need to do here is on no parameters, we want to set up there. One parameter, we want a 3. That's not what I wanted. Setups, multiple. There. Okay, cool. Because then we're setting up the expectations, we're calling them, and then we can, in our benchmark test, verify that. Okay. So what we want to do here is we want to do the same thing, except we want to say here they all fail. And it's easy to do that because we're going to we just won't invoke them. Okay. And now we want the many case. And the many case is we can only do 1 for a no parameter, but we can do like 1, 2, 3, and then here we can also say we expect 1, 2, 1, 2. And then here we're going to say 1, 2, 1, 2, 1, 2. Okay. And many current. One current dot, dot, there. Okay. And now we want a many all fail. Many current. So we're going to do that. We're going to say we never use this. Now what we want to test here, I guess I could get rid of the instance invoked thing, the check here. Because what we're really concerned about is, what does this code do? This stuff has to be here. This stuff has to be here. That's not what we're going to change. Okay. We're just not going to... All right, see you, Electron. That's not going to change. None of this is going to change here or here. What we're changing is this. What I also don't want in the benchmark test is benchmarking when an exception is thrown. Okay. So with the current approach, we're just going to do this. Okay. That's really what we're trying to test here is, what does this allocation strategy give us? And so with no expectations current way, we can also say one current, one x, wait, what are we saying? One expectation, and then we need one expectation, all fail. And then we need many. And I need to change which one it's looking at. Many expectations, current way. Many expectations. Okay, and now no current, we need one current. This is one all fail. This is many current. This is many all fail. Okay. Okay. And so this should give us now the numbers on what happens when... This is really the thing we're testing. What happens when we do a standard failure allocation or what happens when we allocate the list with no hint of capacity, and we're going to use the current way of verify. And actually I could just run this and then put them in a markdown file and then see what the differences are between each approach. Let's do that. Okay, so now do it in the stream while I'm streaming, playing music, because then we get this. Oh, we need to also change here benchmark runner dot run to verify strategies. Okay, so let's do this and let's see what happens. And again, what's the reason why you do this stuff? You need to test. You need to have numbers. You need to do something that's objective. Right? Because if you don't, then there's really no way to determine... You can go on intuition, that's to a certain degree. Like, that's why I'm looking at this going, well, there's a couple of possible things we can do. One, we can set the initial list to a capacity of 0 because we're expecting that you never have anything wrong. So the default is that you should never have anything to report. The other one is to look at, well, what happens when we return an enumerable back? And then what happens if we do both? So we have the current way, we have, let's do it when we return an enumerable, let's do it when we return a list, and then let's do it when we have the capacity of the list to 0, and then we do both of those. So this is the first approach, okay? Current verify. So now we want to have enumerable return verify. We're going to want list capacity equals 0 verify. And then we're going to want and list capacity equals 0 verify. We want 4 cases. Okay, so now what we want to do is we come into verify strategies and we want to say 2. Okay. This is what we just added, and we have to be careful to remove this or change this or whatever, depending upon what we try to do here. So it's exactly the same thing, except we're returning an enumerable. That's it. So if you have failures, they would show up here. But it's through an enumerable. Does this make any difference at all? That's what we're going to try to determine first. Now, part of me says yes, because we should see a little bit of a difference when you have failures. Because we're returning an enumerable. We're not going to return an IEnumerable. We're not returning an array. That's my guess. But again, this is why we do this, is because we want to see, is that actually true? Is there any difference between these two? I love doing benchmarking, and I really love that there's a framework out there called benchmark.net. It is so, so, so nice, because it makes it so that you can do these types of things relatively quickly. And the setup is pretty simple. You know, all things considered, you don't have to set up the framework yourself. You don't have to set up everything yourself. You don't have to do stopwatches, GC pauses, anything like that. Let benchmark.net do the thing you want yourself. Let it do it, and let you focus on what you're trying to do comparisons on. All right, we have numbers. Did they matter at all? Barely. The speed doesn't matter. Notice that. The speed really doesn't matter. It does, like, if you look at many expectations, it does go down a little bit here. It does go down just a slight bit with this. I mean, it is, although up here, all fail, it's a tiny bit slower. What I do notice, though, is in all cases, the memory allocation, other than when you have no expectations, the memory allocations do go down. So that's a winner right there in my case. I think, even though it's not a lot, we're not talking like gigabytes or exabytes, we're talking just bytes. But I'm like, anything that you can squeeze out of this, you might as well. So it looks like changing it to an IEnumerable as a return value to verify is what we want. And what's nice about this is that this should not break any of the code that's currently there, that's generated. What is going to break is if I change the capacity to 0. Okay. Because then all my unit tests will break, because now it's going to generate, in the code, it's going to generate this. Okay. Now, let's change it back to verify. Actually, no, let's don't. Let's just do this. If we're going to go with verify, then what happens if we add in a 0 allocation? Because there's a cost involved in here too. If you allocate nothing, then what happens when you actually do have verifications, exceptions? You have things that are not correct. Then what it's going to have to do is reallocate, because a list is basically a wrapper around an array, and it does reallocations if there's not enough room. This strategy is basically saying your test should pass. You should never have any errors. So in the case where you do have an error, if we have to do a reallocation, too bad, so sad. You shouldn't have done that in the first place. It's a, it's a slight penalty. We're going to see what the penalty is, but to me it's like, well, then you shouldn't have screwed up. Get your tests to work and then everything runs faster. I made a slight change like that too with when you throw an exception and all. You can kind of actually see it down at the bottom there, line 202, that the code I generate calls this get member description based on the member identifier, and that's an extension method that is called a runtime to figure out what the method or what the member description is. So what's interesting is that's actually the way I did it before is I calculated that and I actually put that in the application or in the generated code. And I kind of said, you know what? No. And the reason why is because why bloat the code with what could be this longer description if you never throw an exception. So that takes out a little bit of code, and it makes it so that only if you have an exception do you have a kind of a little bit of a penalty. But I'm like, again, that's kind of the trade-off you make. So now what happens here? Really no difference. Which is kind of nice, because then I don't need to change the list generated code to have a capacity of 0. But it seems like changing it to a IEnumerable makes it just a little bit better. Not a lot, but a little. And that's actually a benefit. So let's look at what I have in my code here. So it seems like that's the approach we want. Okay. And we basically copy pasted the source generated code. What's this? This is a library that I maintain called Rocks. It's a mocking library in .NET, similar to MOQ or Substitute, except it uses source generators. So basically faster and less memory consumption. So, and you can do anything you want in C#. It doesn't have any limitations like MOQ and Substitute sometimes have with things like ref structs. So, among other things. So I think, yeah, in these cases, we're not causing any, and you see that here, like with the numbers that when everything worked, the allocations are low. When it doesn't work is when you have a little bit more allocation. What I still don't kind of like is when you have, why do you have this allocation here at all? Why does that even exist? If I go back down to the verify here, one thought I had is to keep some kind of indicator to say, once you reach the expected call count, because that's the only thing we do a verification on. If you look at the verify call, we're doing this for all of them. We could put something on, but that's on each handler, and I don't think I want to have that logic, because you're gonna have to put that logic in every mocked member to say that the expected call count on the entire set of handlers we currently have for this mock, have we finally hit that magic number? And again, we're talking about bytes. We're not talking about gigabytes. And there is a slight benefit. Again, for the many expectations and they all fail, there seemed to be a slight disadvantage here, but most cases you're not going to get any expectations to fail. Even when you have many expectations, like in our test here, we have, with the many, we set like basically 3 on each of these, which is not a lot, but you're not going to have a lot of expectations when you do testing. So the hope is that actually knocks us down a slight amount, from what it is currently to what it could get to. It'd be just a little bit, but you're also definitely seeing savings on memory. So what that shows me is what we want to do is in this test, we're no longer going to have a verify to, because what we're going to do is we're going to say this verify goes away. And we have verify to. That is now the way to do it. Okay. And so let's run all of our tests on this. Because nothing should break. Should being the operative word. Of course, I know better. Things can go sideways in a hurry. So now our tests are running. They all pass. Let's go through the code generation tests, because that's going to take a little bit of time. Now, the code generation tests don't test like the integration. They just test to see if anything's going to break from a compilation perspective, which, since our unit test didn't break, none of these should break. But again, that's why we have these here. So I think we have a slight winner. So when 10.2 goes through, eventually when I make that release, and benchmark MockNet gets that version, and if, well, they have it so that it sets up the results. They don't publish it all the time, but every merge does the results, and you can see what the results are there. That should show a slight improvement, in the verify. It makes it a little bit better, and I'm happy about that. I'm happy. And then I'll come back to this in a year and try to make it even faster. You know, because why not? It's a never-ending quest chasing that dragon, trying to get things to be a little bit better. So but I'm glad I took the time to go through all the benchmark testing. Now, one thing I want to add in the verify strategies, I want to put a note here. Note. Verify used to return a list of string. These performance tests had a verify to that returned an enumerable of string, which ended up being slightly better. Verify to was removed and verify was changed to return a enumerable string. So I just want that note in there, just so that I come back to this and go, hey, what was that point? Why did I do this? Because it's always helpful to do that kind of work. Put those comments in just to remind yourself, or somebody else, that they're looking at your code going, what is this? Or why did they do it this way? Or what's going on? That's something I've tried to do more over the years. I used to be very much a don't put comments in. Your code should be written cleanly enough that somebody should be able to take a look at it and go, oh, that's what it's doing. I've changed over the years. Like I was taught you always want to comment your code, and then I kind of went to the other way, which is add as little comments as possible. I have now changed my tune, and there's a balance. Like, you don't, XML comments like gets the name when you have a name property on a person. I mean, that's obvious, but it's just a slight little quality of life thing that you can see in IntelliSense, but it's not that big of a deal. I do those anyway, just because they're somewhat helpful, just to have like a simple description about what a member does. You know, keep it simple. But I think it does help in code to say, why am I doing this thing? And there's some things in Rocks that are very much, I go back and look at it and go, I have no idea what the hell it's doing, or I can't tell why I did this or what the point of this was. And so putting comments in your code like this is like, it's free. It's not going to hurt the compiler. You know, I mean, I'm sure you could do tests to show if you compiled a large code base that had no comments in it, and then compared it to compiling a code base that has all the comments in it, that the compilation step with the no comments is going to be slightly faster, because it's not for free. The parser still has to handle all those comments and put them in a tree, and then eventually just evaporate them when you create the assembly, because they're not important. Unless you have XML comments, those, and you want the docs comment, the XML file will be generated. But those are the only, and those wouldn't be put in the assembly. I don't think they get put into the XML file. But just straight comments like this, it's irrelevant. Even the XML comments are irrelevant to a resultant assembly. So, is there a performance benefit in not having comments for compilation? I'm sure there is, but it's probably so negligible, and compared to the maintainability aspect of having comments in your code is so much more worth it. So anyway, a little bit rambling on comments, but it does show that I can change my opinion on things. So, all right, thanks. If you want to subscribe, I'd appreciate it. But I do appreciate the comment. So this should pass. All these tests should pass. There we go. Okay. Now, I do want to keep the changelog kind of updated as I go through this, because performed a number of refactorings. And yes, I could keep these in separate issues so that they're easier to track, but I'm just going to do this because I didn't know which ones were going to be beneficial or not. Improved the performance of verify. I think I did. I think it's improved. So that's good. And as I go through these other things, I might like say, you know, like reduced. And that's what's also going to show is when I do some of these with running all the tests on main and then seeing did that make any difference in terms of the actual generation of the code itself? And is it a little faster and a little bit more memory performant, or consume less memory? The benchmark mocknet tests don't test that. They test just what the mock does at runtime. So it doesn't care about that. Whatever you're doing when you're running your test or your code, that's what it's testing. And with things like nsubstitute and MOQ, it has to generate all that stuff at runtime. At least once. It may cache it, and it probably does cache them because that's much more performant to do it that way. Once you have the mock type, you don't need it. You don't need to do that again. But it still needs to have that one hit. And I think that also kind of skews their tests a little bit because of that performance penalty at runtime. The performance penalty I get is at compile time because I have to generate it at compile time. But I want to make sure that actually is also better as well. Working in enterprise C++ engine-based agents. Well, good luck, sir. I haven't done C++ in 25 years. I think the last time I only did it once. There was a project that I was on in 2001. And this was during my 20 years as I did software. I was a consultant for like 25 years of my life, more or less. 20 years of which were with one company. They were called Magenic. And this client, we were basically taking these mainframe files that were in EBCDIC, which is it's like ASCII, except it's in a different values for different things. And so we need to do an EBCDIC to ASCII conversion because that's what humans want to read, and then that's what we'd send that off somewhere else. I forget all the details of this. But for whatever reason, we decided to build this in C++, and I'm like, well, if I want to be on this project, I have to do C++. So I said to the team, there was like 4 or 5 different teams that were doing all sorts of different things with this. And the team I was on was like 4 people. And I said, look, I'll do this, but I don't want to have 20 different ways to handle a string in our code base. Let's try to, if we keep this relatively clean, then I should be able to help out and get what I need to have done. And we did. We actually ended up coming up with some stuff that was really cool. But do I know anything about C++? No, I've completely forgotten everything. So, no, I'm not really interested in the agents. So anyway, and I do need to remove unnecessary usings when I'm all done with this. So I put that as a bullet point here, but so we did that. Great. How long have we been streaming for? Hour and a half. Okay. By the way, please subscribe to the channel if you haven't already. I really would appreciate it. And then I have a whole bunch of notes here. Some of these just get into, I want to change right line to right lines. And those should be fairly simple to do, maybe. But there are some things I want to take code from 2 things and put them into one and that type of stuff. Okay. So let's just get through them. Might as well. So the first thing we want to look at is, first thing we want to do is commit all of our stuff for OA improved the performance of verify. So let's now go look for naming context. So naming context is a thing that it's used in a couple of different cases. One of them is to basically get the names correct if you're doing variable naming context, because if there is a parameter called like index and I want to generate code that I want to have a variable called index, well, I can't use index because there's a parameter in scope called index. So those are going to collide. So what I've done in Rocks is have this naming context thing set up that I can use in a couple of different areas. One of them is variables, and say, well, here are the current things in scope, like method parameter names. If I want to generate code using index, so that is my key. That's my thing that I'm going to say here. I'm going to put in a variable called index. But what it's really going to put in is index 2, because it's going to realize, oh, I want index. But there's one in scope called that. So what I'm really going to generate is index. What that allows me to do is make the code generation oblivious to what the actual name is. Like, I don't care about what the actual name ends up being. It's going to be something that's unique and is correct from a compilation standpoint. So I think the only thing I put in here is to say gets the name, gets a unique name for the given variable name. And then we can have, not summary, what's the remarks? That's right. If the intent, actually, we can put this here as just kind of like general comments on the naming context. We can say purpose of this class, this type, is to provide a way for the code generation phase to say, I want a variable named index and produce a name that will not collide with other named things currently in scope. What are you trying to make? Well, this is something I've already made. This is a library called Rocks, which is a source generator that generates mocks. So if you've used something in C# or .NET called MOQ or in Substitute, it's a mocking framework. This is effectively the same idea, except it's all source generated. So it's fast, it's at compile time, and compared to these other frameworks, I'm not limited by what expression trees do because they use those extensively. This one doesn't. And I can basically handle pretty much anything and any feature that's in C#. So one of the examples I give all the time is ref structs. I have no problem handling anything that has ref structs. Those other frameworks do. And when you have more of an emphasis on ref structs, like with span, read only a span, that can start to become a problem. So that's what I'm doing. And right now I'm just doing a whole bunch of refactorings that I've wanted to do for a long time that I just have never gotten around to going back and cleaning some things up. For example, if you wanted a variable named index and the method parameters have two parameters. Method parameters are called A, B, and C. Then index doesn't collide with them. Any of them, and the index or getter. Actually, I want a variable named D or value. Let's call it value because I don't want to use indexer. Will return value. However, if one of the parameters is named value, then the getter will return value 2. There. So that way, I just want to put some documentation around this in code just a little bit so that somebody comes back here and says, why is the getter doing what it's doing here? Because it looks really weird, but this gives you a description as to say, well, this is what the getter's doing. And, saying if the names that you're given doesn't contain the variable name, then for the variables I currently want, I will add that in. And then I just return that. Otherwise, if it does exist, or if the names do contain it, and we already have resolved what that variable name should be, then we just return that. Otherwise, now we generate this unique identifier for it and return that. So that's what I was trying to do here. So now that's done. Now this one is a pretty big one because it's based on the naming context. This is a implementation of naming context. I forget what the keystroke is. Go implementation. So there should be a couple of these. Control F12. There's a variable naming context. That's what you use when you're creating variables in a scope. And then there's also a helper one here that can create variable names when you're in a handler, because a handler always has all these things in scope. And so I just return this. In fact, there's probably only one or two places this is, oh, okay, well, I'm mistaken. There's a lot of places this is called. But this allows us just to say, I want a variable naming context based on what I always know is going to be in scope for a handler. So that's what I have here. But there are two of them. And the second one is this type arguments naming context. So there's cases that when you have generic things, either a generic type or a generic method, you can sometimes run into a little bit of a collision. And I don't remember all of the details off the top of my head, but if you have a method, you have to actually look at what the type parameter names are and what your type parameter names are and handle them. You can see that we have a case where we have two constructors. One is for a type reference model, because I have all my own models. That's the thing you want to do in source generators, is that you don't keep semantic model members around, like method symbol. You don't keep any of those symbols around. You really shouldn't keep syntax trees, any of that stuff around. Have your own read-only immutable model that's equatable around, and using things like records or that type of stuff is actually, like, if you look at method model here, that is a record. And so we get equality baked in for all of the properties that we're doing. And all these are simple value type things that we have here. Equatable array is one that floats around all over the place for source generators. So anyway, so we have one for the type and we have one for the method. And I started looking at this and I went, well, wait a minute. If I look at all the places that this is used, like, it's in delegate builder, it's in this method expectations, it's in the mock handler. I'm kind of sitting there going, well, why do we create this potentially more than one time for one method? And if I look at the type reference one, the constructor, it's only used once, and it's used in a very interesting spot. It's what these things called shims, and these things that I have in rocks called shims are there because if you have a default interface member that you don't override, default interface members get really weird. Effectively, I have to route to the base call on default interface member. And long story short is I use this thing that I call create shims, or that these types called shims that basically handle that redirection. The thing that's really interesting is that when I'm saying build here and I'm passing in the shim type, it is here. I'm trying to figure out what is it actually been. It is the actual type itself. Because if you look at shim builder, we're passing in, well, there's shims. Okay, so wait a minute. So we're looking to mock this type. Where does that get set? We're given that. And the reason we're given that is because you could have multiple interfaces that have their own default interface members. And so so there's some code in here that I basically do to resolve that. But if I go back here, and the only place that we're passing this in what I'm wondering here is, why are we passing in the shims type? I'm just curious, as an experiment, why we wouldn't pass in the methods, or just the method itself. Why are we passing in the type? Well, we can do an experiment here, right? We can just say, let's take this, comment that, and then just say, you know what? Why are we doing this? I don't know. I have no idea why I'm doing this here. Let's run the tests and see what breaks. Because something should break, right? I wouldn't have done this otherwise. And if it breaks, I want to understand why. The whole point of why I'm looking at this is because I want to see, could I attach a name type argument naming context, everything builds, to a method. They all pass. And so then I wouldn't have to keep creating this whenever I run into this. There would just be, when you create a method model, we would create a type arguments naming context off of it. And then we would just use that everywhere. Okay, so let's run the big tests. And if we ever need to come back here and say, look, I really needed this to be the type for the naming context, then fine, we can do that. But I don't know why I would actually bother if everything passes. If it doesn't, then we need a tester on that stuff. But you see here at the method, we're intersecting the type that it's on, its type arguments with its own type arguments. So that's why I'm kind of like, I don't know why I did this. You know, and this is why I'm going to be spending time on my code base and doing these streams to go through and refactor this stuff, because I want to make sure that stuff makes sense, you know. Because if it doesn't make sense, we need to make it make sense. And this would actually also get rid of the constructor here. We wouldn't need this one anymore, because nothing else would do it. We just only need it for methods. I don't know if we ever run into a case. Yeah, there are some. But I think these would all go away because they're all doing this. They're all doing this type of thing. And so I think the constructor could also go away. We could do the same thing here, because with indexers and properties, we're saying, well, we can just pass in a nothing, because properties and indexers can't be generic themselves. Methods can, but not properties and generics. So like we get the method here, we could just say property get method, pass that into here, and then that's the one that just got created with the method itself from the property. Again, this is a little bit of a cleanup thing here, that if we can do it, it gets rid of just a tiny bit of noise, and any noise that we can remove is going to be helpful. So let's see what this does. But again, like I have said many times, you cannot do this kind of work without tests. There is just no way to do this. If you don't have tests around your code, and I don't care how you do it, I mean, that I would strongly recommend using a framework that already exists, like NUnit, but write them yourself if you feel comfortable with that. I don't know why, but do that. But write tests. I don't understand how people can write code or generate it or whatever, something that has to be maintained for the future, without having tests that are testing for things that you expect and also testing for things that are expected to fail. Like if I have a parameter to a method that doesn't take nulls, then you have argument null checks around that and have a test to show that. I mean, it sounds simple, but it's like that stuff is, you need all of that, because you have to approach your code like, how would somebody use this if they didn't know what the code was doing? That to me is the only way that you can create high quality code. And I'm not saying all the code I write is high quality, because why else would I not be making all these changes that I want to do? But that's, to reach that kind of goal, you're never going to get there if you don't have tests. Never. That's an argument I'm not going to have with people. Hey, Electron. You know, you either write tests or you're going to fail. So if these come back, then I can change this so that we only have that type arguments naming context on a method. And then we can actually get rid of, I believe, well, we can get rid of the constructor that takes the type. And then we can also get rid of the potential constructor one, because we can go through and find all the places where we're creating them and remove them and change them. Okay. So I think there's 2 phases to this. What we want to do is close other tabs. Is the first thing we're going to want to do is, well, we can, yeah, nothing's coming. Shoot. Where did I? Yeah, this one. No, I want. I just opened the file. That's what I wanted you to do. There you go. We can now get rid of that. Okay. So now we can get rid of this because we know nobody calls it anymore, right? Yep. Okay. What we also want to do now is on a method model. Now you got to be careful here, Jason, because a type argument naming context shoot. Okay, that's a little bit of a stunner. You want to see those agents? No. The problem is that this is not immutable. This is not equatable either. And that's important because it's important for things on these models to be equatable and immutable. And this is actually technically not immutable because as you call get, it does have the side effect that it can add things to the variables. And so we don't want to go to method model and suddenly have to like override how it does equals to not include that. If we want to have a type arguments naming context on everything, that's just not going to work on a method model. That's unfortunate. Well, I got to think about this one. I do like that we at least got rid of one thing, which is we don't need the type constructor. But this is unfortunate because I was really, really hoping to make this so that it's considered equatable, because then I could put it on the method model. I got to think about this for a little bit. If we made naming context equatable, the thing we could do is we could have it implement iEquatable, and then we'd have our own implementation of it. And what we really care about is, are the names the same between two different naming contexts? We're not going to use a naming context, and we could do this just for type. Well, these are private fields, so we couldn't see them on the type arguments subclass. But we're never going to compare on a naming context two different instances that have different variable names. I mean, I guess we could. And say, are those equal or not? The problem, though, with that is when we are doing this here, and then we get this naming context, we're saying build name here, for example. I keep... Go to the actual definition of it. No, not that. This. There we go. We say build name here. Yeah, the build name thing here is weird, to say the least. This is all coming from delegate builder. Arg. I get that this whole build name thing that's another thing that's kind of weird with what I've been doing. I'm not really sure I like what I've been doing with it, but if we can have a type arguments naming context on everything, but the problem is that when we're using it for something like build name here, crap. I keep going to this, and that's not where I want, because the actual implementation is in here. It is possible that we could really screw stuff up with the names of things. The whole naming, the build name here is really... This is the method we want, build name, and then we just pass in this. And I think that was just done because we wanted to not have all that code everywhere in the build name. I'm not sure. I'm kind of rambling at this point. I think we would want to be careful with like if we had a context for every method, the problem is that that's going to be shared in all these other different places that use the context. And that can become problematic. This is a code called Rocks. You can take a look. Let me just put it in the chat here real quick. So maybe not having the context, the naming context or the type arguments is something we want on the method model. I was kind of hoping we could, because maybe one thing we could do is instead of here, because I bet everywhere we're doing this, we're either giving it the method or like we're trying to give it for the current method. And we can have something on method to say get type arguments naming context. And it would just have this on here so that we wouldn't have to repeat this code everywhere. That might be, I think, a somewhat better idea. Let me just check. Yeah, all of them do that. So if we come back to this here, instead of everywhere we're doing this, we could have it because that's the only place it's created is there. And then if I look at this, I think a lot of these are because they could end up becoming from the thing that we're currently looking at, if that makes sense. Yeah, these are properties. These are all from that. I think they would all end up, yeah. Okay, so I think what I'm landing on is it would be nice if I could just say, I don't want to make this a nested type of method builder. Or method model, I should say. I don't want that. But what I would want is just I could put in the code and just say these should only be called from method model, because that's really the only places it should be called from. So I am currently running out of time because I need other things to do today, or I have other things to do today. But I think what I'm landing on with this refactoring is just put a method on method model that says get type arguments naming context. And what it will do is it will say, I'm trying to think here. Would we even need a no argument constructor? Because the reason we're doing the no argument constructor is because we're saying the method is not generic. But what happens if the mock type is generic? I guess what I'm getting at is, could I get away with just having one method here that says take a method model? And then we just say on that one constructor, you know, only call this from here. There's no mechanism in C# to say this is a friend. I know there's a keyword called friend, but this is a friend to only this type. So only this type can call this thing. There's no real easy way to do that. I could make this a nested type of method builder. But then we have the naming thing where everywhere you look, it'd be method model dot type arguments naming context. Which is probably okay because we don't. It doesn't affect generated code. This type does not show up in generated code. So we have to go everywhere in our code and change it so that it now suddenly has method model type arguments naming context. So be it. But we should probably be using var anyway. So what difference does it make? Yeah. Who cares if it's a nested type? So let me get my notes down here. Actually, what I landed on is only one constructor that takes a method model. Make type arguments, naming context, a nested type of method. There's a couple cases where we are referencing type arguments, naming context directly, and we'll have to change that, but it should be minimal. Should be. Create a get type arguments naming context method on method model. So that way when somebody wants it, we'll create it for you. And then you can do with it what you will if you ever modify it. Maybe, I guess, could also check to see if this context is truly ever mutated in the code. Because if it isn't, we could then make it equatable, put it on the method model, and then be one and done with it. But I'm pretty sure we're not going to be able to get away with that. Anyway, I'm going to stop here because reasons. I've got other things to do, but let's at least get this in here for 408. Started work on naming context changes. Perfect. Okay, cool. I'm going to end the stream here and go off and do some other stuff. So I want to thank everybody who's been watching either now or in the future. If you haven't subscribed to the channel just yet, please do so. I would really appreciate it. The next time I do a coding stream will probably be either tomorrow morning or Tuesday morning, or both. We'll see. It's random whenever I feel like it. I will also be doing a gaming stream, at least this afternoon. I'm going to start a new game. I finished Alien Rogue Incursion, which I really liked, but I need something that's much less stressful than that game. So I think the game I'm going to be playing is going to be on the less stressful side of things. We'll see. It's a game I've seen somebody play before, and it's not like a new game, but I don't remember much from it. But I think it should be fun. I think it should be enjoyable. So that's going to start in probably I don't know, 2 or 3 hours. We'll see. But for now, I am done with this stream. Thank you all for watching. Take care, and I hope to see you in the future.